Good morning. Today we are continuing on with that probability with PO73. I can calculate the probability of a single event. So first thing we need to know is remember what probability means. Probability is oh my, I need to recalibrate. Let's try this again. Probability is the likelihood of an event happening. So when we're looking at that, we're going to look at a scale of probability. So our scale is going to go from 0% all the way to 100%. What do you think we're going to put right in the middle of our scale? Alan? 50%. So think about if we're talking about the likelihood of an event happening. If it is 0%, what does that mean? Is our event maybe going to happen? Definitely happen? What does it mean? So it will not happen, right? 0%, not going to happen. Are we going to cancel school today? No, not going to happen. There's a 0% chance of that. We don't have to worry about it being too cold to come to school. Not going to happen. 100% would be what? James? It definitely will happen. Will it rain today? Well, considering it's raining outside, yes. Yes, it will. 100% it's going to rain, because it is. So 50% in the middle, it's a 50% chance. Adeline? Yeah, it's a 50% chance. There's enough likelihood that it will, as opposed to that it won't, right? 50% chance, it's right in the middle. I honestly don't know which way it's going to go. 25% is halfway between 0 and 50. Is it likely to happen or likely to not happen if it's at 25%? Lila? Not likely to happen, right? Because it's closer to that 0% than it is to the 100%. So it's not likely to happen. So when it's below 50%, it's closer to the not happening, not likely. So if we're at 75%, what do you think that would be, Liam?
Likely?
Likely to happen, because we are closer to the, yep, definitely happening. So if our percentage, our probability percentage, if it's below 50%, not likely to happen. Above 50%, likely to happen. So we have a formula to find that percentage. Okay, so we have a couple of different ways we can write it. So we could say what you want to happen goes on top as our numerator. And then what could happen goes on bottom as our denominator. So you make that fraction what you want to have happen over all the possible what could happen. Another way to write this is to say desired outcomes over possible or total outcomes. It means the same thing. In my head, I always think in terms, I really need you to stop communicating with Preston because it distracts me whenever I look at you and you're making little faces, okay? So we're just gonna stop and focus. All right, in my mind, I like to think of it as desired outcomes, what I want to happen, that's what I'm desiring, over total possible outcomes. How many outcomes altogether are there? Then there's going to be on top is just how many I want out of those total possible. Now, when we think about our fractions, remember that fraction bar means what operation? James? Divide. So you take the top number and you divide it by the bottom. That gets us what? What do we get from that? Adeline? What kind of, if we had 5 over 8, we would get a decimal. Yeah. So from there you get a decimal. What do you think we're going to do with our decimal? What do we need to turn a decimal into, Kylie? A percentage. Because remember, we're looking at that scale of probability. We want to turn that decimal into a percent. Now that is math that we did way back in the fall, and it's coming back. How do we turn a decimal into a percentage? We're going to review that as we go through this. So we're going to look at each of our events and calculate the probability of each event. Then we're going to put it down to its percentage. So when we're looking at the probability of the event, we'll put what its percent turns into. So we're going to put the fraction of our desired outcomes over our total possible outcomes, divide it down to a decimal, turn that decimal into a percentage, and then decide, well, is that going to be likely or not likely? If our percent is bigger than 50%, it will be likely. If it is less than 50%, it'll be unlikely. So let's see what that looks like. So I'm just going to put a little note over to the side, reminding us what our formula is. Desired outcomes over total possible outcomes. Okay. So let's look at our first one. We have a bag of 20 marbles. Got marbles in a bag. I'm going to reach my hand in. There are 3 red, 8 blue, 5 white, and 4 yellow. That equals 20 marbles altogether. If I reach my hand in and choose a marble, what is the probability that that marble will be red? So I have to ask myself, what am I going to put as my numerator? How many desired outcomes are there? Maddie? Yeah, we have 3 red, so there are 3 desired outcomes that I want. I want to pick one of those 3. So now I have to do my denominator. What should I put for that? Liam?
20.
Why 20, Liam?
Because the number of all the marbles together.
That's our total number of marbles. So that's the total possible outcomes. There are 20 possible marbles that you could choose from. So we decided what our desired outcomes were, what our total possible were. What's my next step? What should I do? Kylie?
Divide.
Yeah, because remember we're going to divide. What is 3? Remember, you always take that top number, you put that in first. 3 divided by 20. Bridget?
0.15.
0.15. If your number has more digits to it, what number do we always want to round to, Sophie? Which place would that be? You're correct, we round to that second place. What do we call that second place? Say it louder. The hundredths, right? So we've got the decimal, we have the tenths, and then we have the hundredths. We always want to round to the hundredths when we're working with percents. Anybody remember what our magic number was with percent? Remember, Adeline? 100. So we want to round to that hundredth place, because then it's easy to turn that decimal into a percentage. If my decimal is 0.15, what is my percent going to be? Ma'am? 15%. I take that 10 in hundredth place and I make that into my percent. Now the directions also say to decide if it's likely or not likely. If it is a 15% probability of choosing a red, likely or not likely. Got it? Not likely. It is less than 50%. Helen?
If it's 50%, will we not write anything?
If our probability turns out to be 50%, you would say, I honestly don't know what we would write for that. Equal chance, likely, not likely. I can honestly tell you, we're not gonna have a 50% because that gets a little bit harder. But if you did at some point in some homework assignment or on a test, see a 50%, it would be equal chance, equal probability, likely versus not likely. Lila?
If we were to get like a really large decimal, what place would we round to?
When we're working with percentages, what's our magic number?
Oh, 100.
100. So what place, Lila?
100.
The 100th place. Okay? So you will have some where you get a big decimal numbers. Round to the 100th place. We're going to do a few more to make sure. We're going to do this first page together. Okay? So I want you really thinking, what is our desired outcome? How many total possible? So we get that right top and bottom numbers. We're going to divide it, find our decimal, round it correctly for our percentage. What is the probability of choosing a yellow marble? What should I put on the top, Emma?
4.
Why 4, Emma?
Because it's how many yellow marbles
There are 4 yellow marbles in the bag. So my desired outcome is one of those 4. What do I put as my denominator, Emma?
20, because that's how many marbles are in the bag.
20, because there are a total of 20 marbles. What's my next step? Sophie, divide. What is 4 divided by 20? Kylie?
22.
So we've got 0.20, because remember, super important that we go out to that 100th place. That will help us when we're turning it into a percentage. Too many of us, if we were to just write 0.2, would turn that into a 2%. It is not 2%. Remember, we have to go to that 100th place, fill it in with that 0, so now we know what percentage is that. 0.20. Helen?
20%.
20%. 2% is very different than 20%. Make sure you go to that second decimal place, to the 100th place. That was our magic number we drilled in when we were working with percentages. Is 20% likely or not likely? Bridget?
Not likely.
Not likely, it is less than 50. Next one, what is the probability of a blue or white marble? So what should I put as my numerator? How many desired outcomes? Emma,
8.
how did you get 8, Emma?
That's
how many blue marbles for blue marbles?
But our desired outcome is blue or white. So we can't forget about that white. So what do I have to do if it's blue or white? Adeline?
Add them and it's
Yeah, I have to add the blue with the white. So there are 13. Because I can want either the blue or the white ones. So there are 13 different marbles in there that fall into the right category. What do I put as my denominator, Sophie? 20, because there are 20 possible marbles. What's my next step? What do I do now that I have my fraction? Jack?
13 divided by 20.
I divide it. 13 divided by 20. What is 13 divided by 20? Aiden?
0.65.
0.65. That turns into what percentage, Aiden? 65%. Is 65% likely or not likely? Finish it up, Aiden. Likely. Now, what is the probability of choosing a red, white, or yellow marble? What is my numerator going to be? Kylie? How did you get 12, Kylie? You have to add the red, the white, and the yellow numbers together, and that's how we get 12. What do we put as our denominator, Liam? 20, because there are 20 possible marbles in the bag. What's my next step, Natalie? Divide. 12 divided by 20. What decimal do we get when we do 12 divided by 20? Adeline?
0.60.
Yeah, 0.6. And then remember, we need 2 decimal places. We must go to the 100th place. You need 2 decimal places to turn it into a percent. What percent is 0.6? Kylie? 60%. Likely or unlikely? Adeline? Likely. Okay, so this was straight up just working with marbles in a bag. Let's look at our second page. That's going to be our homework. We're not going to work with marbles anymore, but it's going to be the same idea. Same equation. Desired outcomes over total possible. All right, so instead of having to turn back to keep looking at it, you can just write it at the top of your page. Write that formula. The formula we have to know. We're going to be putting it on our help sheets. We need to know it's desired over total possible. So this time, we're still writing likely or unlikely. So we're finding the fraction, dividing it to a decimal that goes to the 100th place, turning it into a percentage, and figuring out is that percent likely or unlikely. Instead of having marbles in a bag, we have letters of the alphabet. There are 26 of them placed in a hat. What is the probability of choosing a vowel? We have to ask ourselves, how many vowels are there? Straight up vowels, not sometimes. Straight up vowels. How many are there? Liam? 5. So what would our desired outcome be? 5, because there are 5 vowels. Out of how many total? James? 26. Okay, so set up your fraction. So if there are 5 vowels, how many consonants are there? There's 26 letters. 5 of them are vowels. How many consonants are there going to be for our next step? How many of us can do that math? 26 letters. 5 are vowels. If they're not a vowel, they're a consonant. Lila? 21. So sometimes when I'm doing these word problems, I like to write what numbers I'm working with so I don't forget. Okay, so if you need to put a 5 over the vowels and a 21 over the consonants so you know what numbers to work with, do that. It's going to help you. Our next one says, what is the probability of choosing a letter before O? What do you think we're going to have to do? Emma?
Do the alphabet before the letter O.
Count your letters. A, B, C, D, E, F, G. Right. Write them all out. Stop before the O. Count how many letters that was. What is the probability of choosing a letter in the words S, V, D, P, royal? What do we have to do, Bennett? Why 9, Bennett? There's 9 letters in there. None of them are repeating. They're all different letters. So count how many letters there are. I do want to show us the second set. That top half is working with those letters of the alphabet. The bottom half says you have a standard deck of playing cards. See the next page if you're unfamiliar with cards. So look at our last page here. We have all of the cards in a regular deck of cards. If you don't know the names of the suits, you're going to want to label them. That top one is the clubs. Then we have spades. And both of those are black colors with our cards. Then we have hearts and diamonds. And both of those are red. So we've got 2 suits that are black, 2 suits that are red. How many cards are in each suit? Going from the ace all the way up to the king. Emma?
13.
13. So each of these suits has 13 cards in it. Okay, so you're going to need those numbers to answer your questions on our homework. So you need to know there's 13 cards in a suit. The diamonds and the hearts are both red suits. The clubs and the spades are both black suits. So if you need to label these, label them. And then you're going to use that information to finish off your answering. Probability of choosing a diamond. What do we have to do to figure out our total possible outcomes? Emma?
You could add all of the 13s together and
Add all of those 13s together to figure out how many cards there are total. That's going to be your denominator. Alright? So add all of those 4 suits of 13 cards to get your denominator. You're going to figure out what your desired outcomes are. So when we're looking at this, if you're not sure about our face names, the J is the Jack, the Q is the Queen, the K is the King. Okay, so it asks about those face cards. It asks about colors. So make sure you know what those cards are that we're working with. Some of us play card games all the time and we just know it. Some of us aren't as familiar with card games. So that's why I'm going through it for those of us who aren't sure. So we've got those face cards, the J, Q, or K, Jack, Queen, or King, red cards and spades, prime numbered cards. What are our prime numbers? Who remembers what does the prime number start with? Emma? It starts with the 2. So our prime number starts with the 2. What comes next? Lila? 3. What comes next? Lila?
5.
Then what, Lila?
7.
7. Because remember, those prime numbers are ones we can't break down. Okay, we can't say, well, this times this. You notice there's not a 6 there because 2 times 3 equals 6. It's only 7 times 1 equals 7. So it's a prime number. It's already down as low as it can go. 8 we can break down 2 times 4. 9 we can break down 3 times 3. 10 we can break down into 5 times 2. 11, can we break that down?
No.
That is our jack. The jack is worth 11. Our queen is 12. Can we break 12 down?
Yes.
Yeah, 4 times 3, 6 times 2. Our king is 13. Can we break 13 down? 13 you can't break down. So those are our prime numbers with our cards. Then the last one was the probability of choosing a 9. Think of how many 9s there are. A black 5 or a red 2. So you have to count how many 9s, how many black 5s, how many red 2s. Okay. Any questions on this page? Okay, quietly do some work time. We've got about 5 minutes of work time. So you may have a little homework tonight. That's okay because a lot of sports are being canceled because of all of the rain. Unless you're in hockey. I doubt hockey would be canceled. Sorry about that, my hockey players. Baseball, softball, and soccer most likely will be canceled. We'll have to see if it's still raining in the evening. Okay, at least during the day it's raining. If you are watching at home, I hope you are well and I hope to see you soon. Have a wonderful day.